So the things, again, we're going to look at, they're going to lead into today's lesson with quadratics. So who can tell me where they see the 8? Elliot?
As the intercept.
Okay. So right here from the graph, right? Oh, I'm not on the right thing. There we go. Where do we see it in the function or the equation? Right?
Next to negative, right there.
Yeah, and that's the constant, right? The b term in y equals mx plus b, the constant, okay? Who can tell us where we see the -2 in the graph? -2, Grant?
It's the slope.
Yeah, so down 2, right 1. Down 2, right 1. There's the -2. Notice it is the coefficient of the linear term. The coefficient, the number in front, the coefficient.
Oh.
It's the -2. I see it on the graph and I see it in the equation. Okay? What about the x-intercept? What is that, Willa?
The x-intercept is 4, and it could be if like a pool is emptying from an amount of time after like 4 hours or something that's empty.
Yeah, so it's easy to see 4 in the context, right? Where it's empty or where something ends. Would you guys agree? Not easy to see 4 in our function? Do you guys see a 4 up there? I'm going to let you know it is there. Here's where. The x-intercept happens when y equals what?
0.
When y equals 0, what would x need to be to make it 8 minus 8?
4.
There it is. Okay, so it's there. You just got to know things and look for it. Notice I didn't say, do this, do this. I said the x-intercept happens when
Y is 0.
y is 0. That's a big idea we already established with linear functions. What about the x-intercept? Sorry, the y-intercept. The y-intercept happens when
X is 0.
x is 0. And when x is 0, look what's left. Right? It's like this. If we go by concept, we don't forget what's what. Right? Go by concept. That's what I'm going to encourage you to do all day, because we're going to see new things today, but it's actually not going to be based on any new concepts. So keep that in mind as we look at the quote-unquote new stuff today. Okay, so we're going to revisit projectile motion. We've done a lot with this. What's the quadratic part of projectile motion we keep seeing over and over?
It goes up and down.
Gravity or distance pulling something, which is 16t squared. Well, if you're talking from the ground, but not if you're talking distance. If you're talking distance, it is 16t squared. Yeah, no, you're not wrong. It's not on my bed. There's more to it. Okay. So here's our function. There's our function. And we've got initial value, we've got a velocity, and we've got the pull of gravity. You're going to say, this goes to yesterday, is it written in standard form? Explain how you know. Here's what Jada got. She got this function. Is it the same? You better justify how you know it is or isn't the same. Then we're going to look at the graph. You're going to get the vertical and horizontal intercepts, also known as the y and x-intercepts. And then you're going to provide context to what those mean in our situation. Okay? This is going to go in your math notebook with your group of 2 or 3. Taking a look at this projectile motion, who can tell me if, for number 1, if it is written in standard form and how you know? Nancy?
It is.
Okay? How do you know?
Later when you simplify the equation, that's what you get.
So it's simplified, okay, and I'm going to identify a constant, a linear, and a quadratic term, right? What makes it standard, though? Which one of those terms is what makes it standard, Micah?
The quadratic.
The quadratic. The linear and the constant could be gone or zeros. It's still quadratic. Hadley?
Technically, according to Khan Academy at least.
Oh, Khan Academy wants it like this.
Khan Academy wants the exponent to come first.
Yeah, but they're the same, yeah. Khan Academy likes it like that if you're trying on Khan Academy. And it goes by, you don't need to worry about this in our curriculum currently, but highest degree to lowest degree term. But,
Highest exponent.
so, let's look at Jada's. Who said Jada had the same? Nobody said, one person?
I did.
3 people? Okay, now, who said Jada's was different? Okay, let's distribute and see what's up. Negative 16t times t is negative 16t squared. Negative 16t times negative 5 is positive 80t. Negative 2 times t is negative 2t. Negative 2 times negative 5 is 10. All right, so This still kind of doesn't look exactly the same, but look at these two terms. Here's my plus 78t. Here's my 10. So what form was Jada's in? Factored form. And was it the same? Yeah, look at it. It starts at 10, goes up by 78 per second. Gravity's pulling on it. All right. So here are both functions, and here's the graph. Who can point out what the vertical intercept is and how they know? Willa.
10 because it doesn't have t after it, so that means
10. 0, 10. So we see it on the graph. We see it on the graph, and you're pointing out, Willa, you always see it here. Is that what you're saying? It's our constant. Okay? You can also see it here. How much time has happened at that y-intercept?
0.
0. So if I'm looking at the factored form, look what happens to these parts of the factored form when the time is 0. They're gone. -2 times -5 is 10. It's there too. It's just a little more hidden. Okay, next. This is where things get cool. Not new concept. New application of concept. Who can tell me what the x-intercept is? What is it, Hadley?
5.
5. Now here's the challenge. So 5, 0. Here's where this is in the function. You guys ready for this? This is where things are new-ish. The x-intercept happens when y equals what?
0.
0. So check this out. If time is 5, right? That's when we said it hit the ground. What's 5 minus 5?
0.
What's 0 minus whatever this junk is?
Negative whatever that junk is.
No. 5 times junk, 0 times junk
Is 0.
is 0. Once t is 5, what's 5 minus 5?
0.
0. And 0 times whatever junk is there is?
0.
0, which means 5 has to be an x-intercept.
How do we get
What?
to the factored form?
You don't have, you're given factored form. We will get to factored form and standard form eventually. Today we're looking at understanding it.
How do we
Okay.
get the 5? It's in the equation.
Look at Raymer. If I did not have the graph, if I can get t minus 5 to be 0, what's 0 times the other junk?
0.
0. So it has to be the x-intercept. I also got it from right here on the graph, though. Now, why aren't we messing with the other intercept, do you think? There is another theoretical intercept right here. Why aren't we messing with that?
Because it's negative and you
Yeah, that's back in time. In context, we started at 10, right? Okay. Just note with this. When we hit the ground, which is this last part, right? The y-intercept is where it starts. X-intercept is when it hits the ground. Okay? We're going to see this, but was there any new big idea? Any new big ideas?
No.
The y-intercept happens when x is 0. The x-intercept happens when y is 0. We did that back in our linear unit, so we're going to continue putting that to work. So these 4, identify the intercepts, then look for them in the graph, please. Am I correct in stating that you could just look at the graphs and pull all the stuff off, right? So do I need to focus on that, you think? No, we're going to focus on where it's at in the function. Let's find all the y-intercepts in the functions first. I think it's the easiest right here. Standard form. 3, 4, -9, 0. Everybody good with that?
Yep.
You can also get them from the last part of your distribution or when x equals 0, right? Like 3 times 1, -4 times -1, -3 times 3, and then 0 times -5. You could do it there, but it's easier in standard form. Everybody agrees? So this next part, for all of our x-intercepts, this is the kind of newish thing. Again, x-intercept when y equals 0. We already know this. So we need to zero these out. How do I get this x plus 3 to be 0? If x is -3. Because it doesn't matter what this is. If x is -3, the whole thing equals 0. Because 0 times this junk is 0.
Wait, couldn't you also make...
Okay, also, this x, if it is -1, -1 plus 1 is 0. 0 times this junk, doesn't matter what that junk is. 0 times that junk is 0. That's why we have 2 answers, y'all. 0 times junk is 0. I bet you didn't expect to hear anything that technical today, did you? Okay, so let's look at function g. If I can make this 0, it works. What would x have to be?
4.
4. 4, 0. It works. If I make this 0, it works. What does x need to be? 1. There it is. It's there, guys. It's based on the same way we get x and y intercepts in a linear function. All right, this one looks a little different maybe. What does this x tell us one of the intercepts is?
Positive
3, because 3 minus 3 is 0, and 0 times that junk, 0. Okay, there it is right here. Okay, this one, what could that x be to make it work?
-3.
And negative 3 plus 3 is 0. 0 times the other junk here is 0.
0.
Last one. This one looks a little different. Okay, so this last one. This one looks a little different. What number would that be to make it equal 0?
5.
5, 0, because no matter what x is, 0 times that junk is 0. This is the one that's a little harder to see once you get used to it.
0.
Yeah, 0 times the other junk is 0. So this one's 0, 0. Here it is. 0, 0, 5, 0. The reason is the x-intercept happens when what?
Y equals 0.
Y is 0. That's it. That's the only thing you need to know. Then the math has to happen. All right? You know what I did in middle school? I did some trash stuff. I got in trouble. But, oh yeah, I wasn't a bad kid, but I did some dumb stuff. So this right here, you know what I did? I memorized if it's positive 3, I know the answer is negative 3. And I had no idea why. So in 2 years, guess what happened?
You forgot.
I was like, I knew how to do it, but I don't remember what I did. You guys think you could forget that the x-axis has a y value of 0? No, that's understanding. That's not memorization. We use concept to make us do math to get to answers, all right? Concept first. You know me. I don't care if you write these down. Let's run this quick. The constant is, what's the y-intercept here?
0. No.
Yeah, the y-intercept 0.
That was my first.
Okay, right here. This x could be
0.
0. This x right here,
5.
5. No, positive. 5 minus 5, 0.
Oh, yeah.
Okay, y-intercept 4.
Yep.
To make it 0, that x needs to be?
-2.
This x needs to be?
2.
-2.
Ooh, one answer.
Oh.
What's the x-intercept of this one?
-2.
What? Of this one?
What's that one?
What's the...
There is none.
There is no x-intercept for that. Let's go. Okay. That's all we need from that. We're going to do a little card sort activity next, okay? I'm going to pace this up a little here because the next part is what will take more time. So a of x, that is standard form. I have a quadratic term. Nothing left to simplify. B of x, neither. What type of function is this, everybody?
A linear.
Linear. Linear function. C of x, factored form. I've got two linears multiplied by each other. D of x, factored form. Linear times linear. E of x, neither. That is an exponential function. F of x, factored. I've got a linear times a linear. G of x, standard. I've got a quadratic term. H of x, neither. So I do have linear times linear, but I also have this constant chilling. And then J of x, standard.
Wait, why is H of x neither?
Because the constant right there. If it was just x minus 2 squared, it would be. It's the constant. It's a different form that we haven't discussed yet. Okay, cool. So next in your directions, it tells you BE and H of x, not options. For number 3, you're going to try to find the function that matches each graph. Okay, I'm going to give you the answer and how I know. For number 3, the first one. The first one is f of x equals x plus 2 times 2x minus 6. Let me tell you how I know. The x-intercepts work. If this x is what? Negative 2. I get 0 times junk is 0. If this x is 3, I get 6 minus 6 is 0. So there are my x-intercepts. Everybody see those?
Yes.
Right? I need to get it to equal 0. 0 times junk is 0 for an x-intercept. Now for the y-intercept, it's when x equals 0, right? When x equals 0, I've got a 2 times negative 6 here. What's 2 times negative 6? Negative 12. 2 times negative 6 is negative.
3 for 2x for the x-intercept.
Because 2 times 3 is 6, and 6 minus 6 is 0. Raymer, you could do this. If I want that to equal 0 and then do 2 steps of algebra, you can do that too. Okay? For the second one, I use the y-intercept. Okay? So if a y-intercept is 6, but you can also test out a number. Let's test out 2. If I put 2 in here, what should be my output?
2.
Output should be 2, 0, right? If I put in 2, my output should be 0. So negative 8 plus 2 plus 6, 2, 0 works. So I just tested a point. All the points on the graph have to work in the function. The last one, I got a of x. X squared minus x minus 6. Check out my y-intercept. It's right there. And then you can always test out another point. Let's test out point negative 2. Negative 2 squared minus negative 2 minus 6. I've got 4 plus 2 minus 6 is 0. Look at negative 2, 0 works. So if you know a function and you know a point, your point better work in your function if you pick that function, okay? Substitution. When kids screw this up, they forget to square first usually. So don't do that.
Wait, what about the other one?
What about the last one?
What last one?
It says you will have 2
Oh, we're gonna stop right here for today. Yep.